So today I'm gonna just solve this shit. I kind of wanted to record my reaction to the to the puzzle, but I was kind of impatient, so I looked at the problem right away. Yeah. I'm gonna read it for completeness. Oh, and I didn't read the second part yet. I didn't even solve the first part. I'm gonna be solving it on the stream. So, equipped with a new understanding of teleporter maintenance, you confidently step onto the repair teleporter pad. You rematerialize on an unfamiliar teleporter and find yourself in a vast underground space which contains a giant playground. Across the playground, a group of elves are working on setting up an ambitious Christmas decoration project. Through careful rigging, they have suspended a large number of small electrical junction boxes. Oh, I see. I see what's this. A large number of small electrical junction boxes. Their plan is to connect the junction boxes with long strings of lights. Most of the junction boxes don't provide electricity. However, when two junction boxes are connected by a string of lights, electricity can pass between those two junction boxes. The elves are trying to figure out which junction boxes to connect so that the electricity can reach every junction box. They even have a list of all of the junction boxes' positions in 3D space, your puzzle input. For example, this list of 20 junction boxes. This list describes the position of 20 junction boxes, one per line. Each position is given as x, y, z coordinates. So the first junction box in the list is at x equals 162, y equals 817, z equals 812. By connecting these two to save on string lights, the elves would like to focus on connecting pairs of junction boxes that are as close together as possible according to straight line distance. In this example, the two junction boxes which are closest together are these two. I'm gonna read the numbers. By connecting these two boxes together, because electricity can flow between them, they become a part of the same circuit. I'm not sure how to what to pronounce this. Let's look it up on. I want to Google Wiktionary. Circuit. Oh, by the way, I completely forgot about the music. I think it's kind of loud. Yeah, it's at 100%. By connecting these two junction boxes together, because electricity can flow between them, they become part of the same circuit. After connecting them, there is a single circuit which contains two junction boxes, and the remaining 18 junction boxes remain in their own individual circuits. Now, the two junction boxes which are closest together but aren't already directly connected are these and this number. After connecting them, since the first of these is already connected to another junction box, there is now a single circuit which contains 3 junction boxes and an additional 17 circuits which contain only 1 junction box each. The next 2 junction boxes to connect are these and these. After connecting them, there is a circuit containing 3 junction boxes, a circuit containing 2 junction boxes, and 15 circuits containing which contain 1 junction box each. The next 2 junction boxes are these two, because these 2 junction boxes were already in the same circuit, nothing happens. This process continues for a while, and the elves are concerned that they don't have enough extension cables for all the circuits. They would like to know how big the circuits will be. After making the 10 shortest connection, there are 11 circuits. 1 circuit which contains 5 junction boxes, 1 circuit which contains 4 junction boxes, 2 circuits which contain 2 junction boxes each, and 7 circuits which each contain a single junction box. Multiplying together the sizes of the 3 largest circuits, 5, 4, and 1 of the circuits of size 2 produces 40. Your list contains many junction boxes. Connect together the 1000 pairs of junction boxes which are closest together. Afterward, what do you get if you multiply together the sizes of the 3 largest circuits? So let's get into it, I suppose. Let's create a directory for the day. I can't type. Let's get our sample input. TST. And let's get our input.txt. Let's get our actual input. Not sure if I... Okay, I'm sure now. I saw the numbers. I saw similar numbers. So... we gotta parse them line by line, I suppose. Let's just allocate like large... I mean, no, first we have to define some types. And I think this is going to be the first puzzle where I use std-end. I actually like already thought on solving this puzzle for a while because I read it some time ago. And I think that points could be in 32s. X, Y, Z. And then it could have layers, which are like which are indices of points in some kind of array. Let's create such an array. And we also gotta store the distance between these two. You're going to store the distance squared because taking the square root, first of all, taking the square root is simply expensive, and also square root will have to be like in either a float or a double, and it loses precision and stuff. And here it's just an integer. I think that's better. You don't need to take square root of distance in order to compare distances between points, so it works. Gonna also allocate pairs. This is probably too large. Probably. Actually, the size of this is more like 1000, then plus 999 plus 9998 and so on until you get to 0, but too lazy to think about that. We also need to like know the sizes. Points count and pairs count. We also need to know how many of them we have in the buffers. I don't know if we'll need like pairs in part 2, so I'm gonna put the pair code in part 1, but the points themselves I wanna parse them in the main. So I'll do just that. I had like a function in one of the days where I could simply get a line, parse range. Yeah, here, parse line. Okay, I can put it here. Okay, so while fe of not fe of stream, if parse line stream line is const char line. Shouldn't be just not, it should be like not equal to 0. If it doesn't equal to 0, then we continue. Otherwise we try to parse a point out of this line. Which is simply like we're going to have x which is equal to 0, then y which x equal to 0, y equal to 0, and z equal to 0. And like, while is digit, oh, and we can also have int I. While is digit line I. Do you have C-type at top? Yeah, we do. Oh, I completely forgot to remove the code out of the parts. So while while we see a digit, we can simply multiply x by 10 and add line I minus 0 character out. And this is going to like add this is going to be like parse the number digit by digit and write it into x. And then you can simply increment y. I mean I, not y. Then you can simply increment I and go onto the same thing for y and onto the same thing for z. Of course, we assume that the input is correct. Actually, why not just do it like a point right away? Make it a point right away and replace. Just add some kind of key point next to it. Then we add it to points. Like this. So this should parse points, but to make sure I wanna print the points. Int I is less than points count I plus plus. Just to make sure. Print F. Oh, by the way, I wanna remove the vocal version of this track. So D, and D. Points I, X. Actually, could have some kind of point P here, and it will equal to points I, so that you don't have to rewrite this long word every time. Py and Pz. And after that we return. There aren't any errors. Awesome. If we try to parse test, it will turn out that we forgot the new line. Yeah, so here's the input. It simply prints the input. Alright, so we parse the points correctly. I want to put this in a separate function simply to like keep I'm gonna call it load points. I wanna call it load points instead of parse points, because like when I call a function parse something, I usually have an output variable, output argument. Here I don't have an output. Here I just don't have an output variable. Actually, it doesn't matter. It's just called parse points. Parse points stream. And we don't need these file functions. We can even just close the file after that. Focus dispatch gcc ggdb main.c. Then I'm gonna fuck. And then I'm gonna run it in a separate, like, I feel like the music is kind of loud. Okay, so advent of code 2025 8. And now I can rebuild. No, I can't rebuild it. Too many arguments. Yeah, this is too many arguments indeed. Okay, so now we can go on to generating the pairs. So for each points count. For each point, we're going to create a connection with all other points. I'm gonna connect them into a pair. Phase less than points count j++. So pair. Okay, so we gotta put the IDs in here, IDs of points. And then we gotta calculate the square of the distance, which is going to be point P1 points I point P2 point J. Okay, so for that we have to for that we have to calculate the relative distance between them. P1x minus P2x. It doesn't really matter what order we take for that. Because like the absolute value, regardless of order, is going to be the same, and then we're going to square these values. So and they'll like become, they will become, what is it called? I forgot. They will become positive anyways. xr plus yr plus zr. But that there's no negative values in there. I just kind of want to make it in32 instead of u in 32. I get so many notifications, for fuck's sake. Right. So we got all of these pairs now. Now I have to sort them by distance. And there is a cool function in C standard library called qsort, which sorts an array for us. Sorts and memmed elements of size. The base argument points to the start of the array. It's called qsort, which is supposed to mean quicksort, but actually it's probably some other implementation of sorting. So yeah. I wonder if it's guaranteed to like not mangle them around. Not that it matters. Okay, so there's base, which is our array. Then there's nmemd and memb. The number of elements, size of each element, and a comparison function. So basically, we have to provide a comparison function for the sorting, so that it can compare things in it. Compare pair distance. Void pair 1, void pair 2. I'm gonna add underscores to them, because I'm gonna convert them to another kind of pointer. So pair 1 equals pair 1 underscore. I can probably remove this window. All I need is the definition. Yeah. I'm gonna put it in here. And I'm gonna specify arguments right away. So pairs and memb is pairs count, and the size is size of pairs element. And we already have a function for comparison, even though it's not fully implemented. So I'm just gonna write it here. Compare pair distances. Compare pair distance. So we've got these pointers. And like, what this function is going got to return is an integer, which is negative less the which is negative um if pair 1 is less than 2, positive if pair 1 is greater than 2, and 0 if they are equal. So all I got to return is probably pair 1 dsqr is more than pair 2 dsqr minus the same thing, but with the other sign, the opposite sign. But I actually want wait, no, I want the least distances to be at top, so this is correct, probably. Now let's see if this compiles. Expected something before size of. Oh, I see. I've accidentally put the definition in here instead of a call. Implicit declaration of QSort. QSort is part of the standard library, stdlib. Alright, passing argument 4 from incompatible pointer type. Oh, we gotta make them const void. And then we gotta put consts in here. Alright. Now let's try to print the first 1,000 pairs I mean the first 10 pairs, okay. I is less than 10, I plus plus. Oh, and also I is less than pairs count, just for safety. In P1 equals pairs I P1 and I'm gonna put this in points like this, and P2 is going to be this point, then just printf. P1x, P1y, P1z, and the same thing but with P2. Alright. Undeclared. Why undeclared? Oh, wait. Accidentally put commas instead of points. Didn't print anything? Oh, it's because we returned before calling the parts. And of course I forgot the new line. As always. So yeah, just as it says, these are the closes. Then another closest pair is this. The next closest pair is this. And this. So we got it. Kind of. We kind of got it. Now we need to connect them into circuits. Okay, so what I was thinking is that we're going to have like an array of circuits, which is just an array of integers, and these integers keep track of how many points. These integers keep track of how many points are in this circuit. And I also want the points keep track of what circuit they're in. At most, there are the same amount of circuits, and there's the same amount of circuits as there are like points at most. Okay, and at the beginning we should assign each point its own circuit. Because at the beginning each point is located in its own circuit. What we have to do at the end is that we have to find the 3 maximum values in circuits. Alright, so points I circuit equals I. Maybe at some point we'll have to convert like circuits in its own type. Oh, and we also need to like set each circuit to 1, because they all have like 1 point in them already. So now we have to make 10 shortest connections in here. For this specific example, it actually has to be 1000. Okay, so how do we connect points like in pairs to their like circuits and stuff. Actually wonder how large these arrays are. I guess I can just print that. Printf size of points equals, I don't know, size of dude, why do I need this thing? Size of points and size of pairs. Size of pairs. Point count undeclared. Declared. Yeah, it's actual points count. These are pretty large structures, especially pairs. I mean, buffers, rather. Alright, so we sorted the pairs, and now we need to start adding points from each pair into circuits. Why did it stop? Alrighty, so pairs, for I in pairs count, and I is less than 10 for this case. Kind of don't like how they made the conditions for the example and for the actual input different, but I guess it makes sense since this what is it called? Since this problem is kind of more complex than all other problems. Alright, so how do we connect them into circuits? Let's get the pair. So pairs I. And I kind of want to get the points as indices here. Okay, so damn. This is so hard to think about. And I also think that circuit just being an integer doesn't really work. Yeah, like if we have two circuits and these two circuits become connected, all points in these circuits have to like become connected. Yeah, all points in these circuits have to become connected. So each circuit has like each circuit has to keep track of what points are in the circuit. Um, hmm. Maybe each point could have like some kind of next point. And then the circuit has to like keep track of its size and also the first point. Ah, no, next. This value plus I don't know. Maybe it should be like FFFFF. Or maybe I should call it empty? Yeah, let's call it empty. Or whatever. Then this type def has to be a circuit. Am I even writing this word right? Yeah, so at the beginning, each point is a member of its own circuit. So each point contains like a piece of data of its like circuit. Oh. Mm, 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 mm. Okay, so I kind of have to figure out how to link circuits. I don't think it's going to be that hard. Hmm. All right. So when we connect these two like points, we have to we have to link the circuits that they are in, right? Let's figure out how to do that, I guess. We also need to keep track of the circuits. Okay, so point P1 circuit. Here it's the same thing. I spent an hour just thinking. This is very complicated for me. um, this is so hard to think about. Okay, so if C1 and C2 are equal, I think we just have to continue. So it doesn't matter. Otherwise, we have to connect these circuits. It means that one circuit starts including it means that one of the circuits starts including all of the elements of the other circuit. All of the elements of the other circuit, and the other circuit stops existing entirely. Maybe it will help if we keep track of like start and end of each circuit. Start, end. Um, let's put this in part 1 though, instead of the main function. Alright, so if if all of the elements in the second circuit become part of the first circuit, it means that all circuits also have the size of 1. It means that the size of the first circuit will increase by the size of the second circuit. It also means that, like, the last point it also means that the last point like the ending point of the first circuit will start pointing at the beginning at the first point of the second circuit. Alright, that makes sense. So, like, I kind of need to visualize it. I don't have any... Oh fuck, what the fuck is edge paint? I think I opened some kind of program. Oh, no. I don't want a random program show up on my screen. I don't even know what's edge paint. Okay, I don't see anything appearing. Whatever that could mean. Okay, so we have, like, I'm gonna put it in some kind of comments. Okay, so we have C1, which points at, like, at some kind of first point in it. And also points at the end at its end. And then we have a similar thing here. So yeah, P3 has to start pointing at P4. So yeah, this this point at the end has to start pointing at the beginning of the other circuit, and then the end pointer of the first circuit. I had to put size in here. The end pointer has to start pointing at the second circuit's end. And I guess that's about it. And we also have to set the size of the second circuit to 0 and empty its pointers. And then we have to sort the circuits by size. Compare circuit size C1, C2, C1, C2, C2, C1. Circuit wait. I forgot a very important thing. Every point also like points at its circuit. So like, okay, for int I equals circuit start while like while I does not equal empty, at the end I is equal to point I next, because it's a linked list. So like point I circuit equals C1. So like we increase the size of the circuit, the the pointer at the end of the point at the end of first circuit starts pointing at the beginning of the second circuit, the first circuit's end becomes second circuit's end. Every point from the second circuit starts pointing at the first circuit, and then we empty the second circuit. I think this should work perfectly. I think, but we also need to compare circuit sizes at the end. Okay, so that also basically means that we fucked up the it also basically means that we kind of are that we are going to fuck up all like circuit pointers, circuit indices within points. But at the end of the problem, I don't think it matters that much. Okay, so circuits, pairs count. This should be like points count. Compare circuit size. Error point undeclared. Where is there? Where is that? Yeah, because it's points. Okay, so printf. Int result equals 0. Result plus equals circuits 0 size. Circuits 1 size and circuits 2 size. Oh my gosh. There's probably some kind of infinite loop. Because I only run 10 steps. But let's replace this with J. Just in case. Yeah, I probably fucked this part up. I think. So it starts pointing. It starts pointing at the start of the first circuit, I think. Is that right? Of the second circuit. And then it continuously takes like the next point until it's suddenly empty. Oops. Open the images. Oh, it's because we gotta um we gotta sort in the other direction here. Yeah, it's 11, but we gotta produce 40. Oh, it's because we have to multiply them. I forgot. Yes, so let's replace this with multiply, and it's 40. All right. All right. This is hilariously large. By the way, after sorting the array, if we want to unfuck, like, after we sort the array, all the, like, circuit pointers within points become fucked up. But if we want to unfuck them, we can just, like, start iterating through each individual circuit like this, and set the circuit pointer within point, like, back to this, like, normal pointer to its own circuit or something. Alright, so the result is probably going to be large, so let it be int 64t. Oh my gosh, I'm kind of nervous about this. Okay, so this has to be raised to a thousand, and then we start iterating through the input. Your answer is too low. How many of them, how many of them is there, by the way? There's 1,000 of them. Why did they get an even number like that? It's probably equal to 0 here because there's only one circuit at the end, which is of size like 20. So if I comment these two multiplications out and build it like this, it's going to be 20, yeah. What the fuck, what did they change? Is there some kind of memory corruption or whatever happening? I can try to increase the point buffer, I guess. That doesn't really help. Oh wait. Okay, I actually want this to be ll_int because I'm printing it. Type def l long int ll_int. I have no, completely no idea what went wrong. What if I print them separately? It's kind of really weird. Maybe it makes sense to debug it. Okay, sort, pairs count, compare distance. I'm pretty sure that, like, the pairs themselves are okay. Okay, I don't get this? Ah, ah, ah. Yeah, let's try to bring it back to 10. And it's 40. That's reasonable. Let's try to print these numbers too. Okay, now it's 12 all of a sudden. Maybe there's something weird happening with, like, integer limit. Also, I think these have to be uint. It doesn't change anything. And I also think these have to be uint. Doesn't change anything. I feel like I'm just fiddling with some uninitialized data somewhere. mean, I do initialize this. I do initialize circuit in each point, and I do initialize each circuit. Each circuit is just this, it's just size, start, and the end. This value changed a bunch of times for no reason, by the way, like without any changes to the code. Oh, well, wait. Connect together the 1,000 pairs of junction boxes which are closest together. I kind of did. I make it so that points make it so that points in circuits like end, make it so that circuits, make it so that point at the end of the first circuit points at the beginning of the second circuit. Then the second circuit stops existing per se. Make sure you're using the full input data, input txt. No, let's try pasting it one more time. My dumb or what? Let's assert that is empty. Assertion is okay. Assertion works okay. I don't know, maybe for circuits 1. Assert that this value assert that this value is equal to C1. Assertion still goes. Like, it's like I'm doing everything correctly. And it just doesn't work. I simply have no idea what could possibly go wrong. I kind of don't like that these are integers instead of unsigned integers. And I've been sitting for 30 minutes and I just don't see what's wrong. Wait, I don't get it. been I've been sitting here for 30 minutes doing nothing because I simply have no idea what's wrong. Maybe maybe this thing will like point me at something really wrong. This thing can become something like huge numbers. Wait, is it a... Should it actually be this large? Like... Because this is huge. XR, XR, YR, YR, ZR, ZR. Wait. I have these parentheses. I have these parentheses. Oh, wait, it's regular integers. It probably does this because, like, it goes over over like the limit of integer limit, and like only after this happens, only after it happens, it converts it to an like. Only after it happens, it converts it to a 64-bit integer. Alright. I hope this did something. These numbers look much more natural, I suppose. Yeah, I didn't provide an actual answer. Accidentally. That's not... Your answer is too high now. Maybe I can convert these, like... in 64T before that. No, I don't think any of this really does anything. I'm pretty sure, like... No, it still affects the result. It still affects the result. Why changing types in absolutely random places changes the results? Like, oh my gosh, let's actually set this to 1000. If you set this to 1,000,000... No, this is not 1,000,000. Okay, what if I change the type of the count? here. Did I... See? The language of fucking gods. Maybe the result changed and I didn't notice. No, it's still not the right answer. Wait, why did... Like, I noticed that changing the number here changed the answer it gives. I'm probably becoming crazy. Man. Okay, let's change all uint16s to uint32s. It changes nothing. Bored of this music. Bored of this music. I'm bored out of my mind, to be fair. This is kind of insane. I see basically no reason, like anything bad here would happen except for, I don't know, some integer overflow. And the reason, like, it doesn't work is it's probably integer overflows. Somewhere, somewhere. I have no idea where. Let's, instead of initializing the next here, initialize it here. Point undeclared. Oh, oops. Okay, let's try to debug it again. The part 1, run input, break here. What are these numbers? Oh wait. Oh wait. Oh my gosh. Okay, let's start again prematurely. B part 1. Run input. Okay, continue here. Oh no, the locals, and get more locals and shit. Get more actual numbers. It is 0 pair, I guess. Distance that looks like a pretty decent number. Let's try to calculate this number using a calculator and see if it's at least close to what it should be. The 3 is here and all other digits are here, so it seems okay. And then it simply inserts it into the array. Okay, so I'm pretty sure the pair part is okay. Let's see a few steps more. I mean, just one step, really. I have no idea what happens here. Oh, and the circuit endpoints are equal at this point because, like, uh, what is J? Ah, they are equal at this point because, like, at the very beginning of the program they are equal, and we haven't, like, merged any of them yet. Okay, whatever. I don't wanna spend time doing useless shit, even though I've been doing this for a long time already. Alright, let's see if this is the right answer. The elves were right. They definitely don't have enough extension cables. You'll need to keep connecting junction boxes together until they are all in one large circuit. Continuing the above example, the first connection which causes all of the junction boxes to form a single circuit is between the junction boxes at is between the junction boxes. The first connection which causes all of the junction boxes to form a single circuit is between the junction boxes at this point and junction boxes at this point. The elves need to know how far those junction boxes are from the wall so they can pick the right extension cable. Multiplying the x coordinates of those two junction boxes produces this number. Continue connecting the closest unconnected pairs of junction boxes together until they are all in the same circuit. What do you get if you multiply together the x-coordinates of the last two junction boxes you need to connect? Alright. Well, let's get rid of these numbers. So this is the first part. We need to keep doing the same thing, and then when there's only one circuit in the entire thing, which means that the size of the circuit is equal to the number of points, uh, which means that the size of the circuits equals to the number of points. We like kind of stop executing, I guess, and print the answer. If this new size is equal to the number of points, then result equals points p1 x multiplied by p2 x, and then we break, and then we print the result. What the fuck? Are you going to have me believe this is the actual number? Wait, it's different on every start. Oh, right. We sorted the circuits before. We sorted them. We sorted the circuits before. Now we need to fix all of the circuits. I is less than, I don't know, point count I plus plus. Okay, circuits I is equal to I. I'll try. That's the right answer. Oh my gosh. I spent, I think I spent I think I spent over an hour just figuring out like the types of things so that I can avoid integer overflows. We have to ditch unsigned integers. We have to ditch unsigned integers entirely. In fact, what if I replace literally all unsigned integers here with actual integers? With like unsigned, with signed integers? Like, will it break anything? Because I don't think so. I think it broke something. Okay, I take my words back. Not about the ditching though. We still should ditch unsigned integers. Return to Advent calendar. I, I I really like this puzzle because it kind of forced me to think about these linked lists and shit. But man, I spent an hour uh trying to like understand these trying to understand where the integer overflow errors happen. It kind of it kind of like it had a bad effect on like on the experience from the puzzle. Oh, also, I think that I kind of have to connect the first and second puzzle, this first and second puzzles in the code, because like mm, because they literally happen sequentially. I just do part one. I don't do any I don't do any reinitialization for part two. Oh. Well, okay, this is awesome. I kind of just wanna read I kind of just wanna reread the code now to see what I was doing. So each point has a pointer to its circuit and to the next point in the same circuit. This is literally a linked list, which has some additional data in it. I think linked lists usually don't save size, but I might be wrong. Most linked lists do save start and end, though. And I don't know, like, how do people usually use like linked lists? Do they usually use doubly linked uh linked lists or like one linked list? I have no idea. Whatever. Uh, I'm tired from this. I spent I spent like I spent most of the streams just staring at the screen trying to understand what's wrong. Absolutely horrible. I'm traumatized. This puzzle traumatized me. I wonder if making this an integer will break it. It won't. I mean, a signed integer. It was integer all along. Also, I kind of have to like write in the name of this function that it actually like does it in reverse order. Da 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 da. Okay, I started singing. Okay, whatever. It's time to end the stream. Bye. I love everyone who watched this. It I said that in the wrong order. I said that in the wrong order, for fuck's sake. Okay, whatever. It's time to end the stream. I love everyone who watched this. Bye.